Hello everyone. In this video we're going to be continuing section 4.2, graphing quadratic functions. However, this time we are going to talk about intercept form. Alright, so a little bit of recall of what we have so far. Y equals ax squared plus bx plus c. That is standard form. Alright, and we have a couple of different pieces of information that go along with that. My a value, if a is positive, it opens up. If a is negative, it opens down. 0, comma c. C is my y-intercept. And then I have the axis of symmetry, which is the opposite of b over 2a. And that is also the x-coordinate for my vertex that I want to input. Alright, and then I had yesterday the vertex form, which is y equals a times the quantity x minus h squared plus k, where my vertex occurs at h comma k, and my axis of symmetry occurs at x equals h. Alright, and there are a couple of other pieces just like before. Where a is positive, it opens up, a is negative, it opens down. Alright, and that a value in all of these affects that stretch and shrink, whether it's a little bit more narrow or whether it's a little bit wider. So we're talking about a champagne glass versus a fruit bowl. Alright, here in intercept form, it is written a third way. Y equals a times the quantity x minus p times the quantity x minus q. Alright, here it's called intercept form because I'm given two x-intercepts. I'm given 2 points where my graph actually crosses the x-axis instead of vertex form where I was given the vertex. So here, the x-intercepts are p and q. So the very first thing I want to do is I want to go ahead and graph p comma 0, q comma 0. And then my axis of symmetry is given by this formula. If I know that I have these 2 points right here that I'm bolding obnoxiously, I know that the axis of symmetry has to be exactly in the middle. So what do I do with that? I actually take those values and I add them and average them out. Okay, so I do p plus q divided by 2. And that gives me my axis of symmetry. So then if I plug that in to my equation, in for x, whatever that value is, I'm going to get out a y. And that is going to be my vertex. And just like in the other two forms, if a is greater than 0, it opens up. And if a is less than 0, it opens down. So let's go ahead and look at an example. Here in example 3, the first thing I want to do is identify what p and q are. It's still written in such a form where the inside, I want to think inside opposite. So here in this case, p equals -3 and q equals 1. So I have 2 points here, -3, 0, and 1, 0. 2 different points. So I want to go ahead and graph those. That's the very first thing I want to do is graph those. And then, step 2, I want to take -3 plus 1 and divide it by 2. I want to use my formula. The axis of symmetry equals p plus q divided by 2, -3 plus 1 divided by 2, which is -2 divided by 2, or -1. So, once I get down, I don't know, sketching it out here, I've got my -3, I've got my +1. You might be able to see right away, yeah, alright, the middle is right there at x equals -1. So I'm going to label that x equals -1. And then I'm going to take that value and I'm going to plug it into my equation. Alright, I'm going to substitute that in for x and I'm going to work it out. So I get 2 times the quantity, 2 times the quantity, -2, and that's what gives me a -8. So my point here is -8, or -1, comma, -8. That's my vertex. So now I've got 3 points, and my axis of symmetry, which I should have drawn on there as a dotted line. All right, and that gives me a pretty decent curve. Now, I'm going to go ahead and tell you guys that one thing I'm going to require of a parabola, I think that 3 points is actually not enough to really give me a good curve. I'm going to actually require 5 points on all your parabolas. So I've got -1, I've got a +1, I've got a -3, one easy point to plug in. Go ahead and plug in 0. All right, into my equation, and I'm rewriting my equation here. Y equals 2 times x plus 3 times x minus 1. All right, so if I'm inputting 0, I get y equals 2 times 0 plus 3 times 0 minus 1, which is 2 times 3, 2 times 3 times -1. So that becomes a -6, and you can see that point right there. And then you would reflect it over the axis of symmetry. 5 points gives you a much better picture, all right? That's going to be easier to draw an accurate curve. So let's continue on with example 4. The path of a place-kicked football can be modeled by the function -0.026x times x minus 46, where x is in the horizontal distance in yards, and y is the corresponding height. So how far is the football kicked, and what is the football's maximum height? So I need to break down what it's actually asking for. So I need to keep in mind this is a real-life problem. All right, it is a negative parabola. You know that it's starting at the ground. It's going to go up and come down. You know how a football is kicked. So I'm looking for that distance. All right, when it hits the ground, when it comes back, or when it starts the ground and when it hits the ground. I'm looking for the distance. And then it's asking for the maximum height. What are they actually asking for? For your vertex, they're actually looking for that y value. All right, the y value of your vertex. So I want to go ahead and rewrite this function. I'm going to rewrite it into vertex form. So originally I had -0.026x times x minus 46. If I go ahead and kind of separate it, if I separate it, I like undistribute here, I can actually write it in intercept form, all right, by adding or subtracting a 0 there. So because p equals 0 and q equals 46, those are my x-intercepts. So purely from that, that's where it's starting and where it's ending when it leaves the ground and when it hits the ground. So the total distance there is 46 yards. And then part B, in order to find the maximum height, we want to calculate the coordinates of the vertex. So I'm going to take my two x-intercepts and average them out. All right, I'm finding my axis of symmetry there in the x-coordinate of my vertex. And then that's not enough. That's the x-coordinate. I don't need to know how far it went. I need to know its height. So I need to input that 23 into my equation, which I am going to round, even though we already talked about how rounding burns bridges and people die. Here it is approximately 13.8. And I do want you to keep in mind that read your directions. They might say round to the nearest tenth, round to the nearest 100th. Follow your directions. So actually answering my question here, the maximum height is 13.8 yards. All right, and if you're trying to approximate, that's about 14 yards. Multiply that by 3, and that is going to give you 42 feet. 42 feet in the air. All right, so the next time you're at a football game, look at that placed kick and see if you think it hit 42 feet in the air. All right, in guided practice, label your vertex and your axis of symmetry and your x-intercepts. All right, so it's going to be very important that you put those points down and you write the coordinate pairs next to it. I do want you to keep in mind how it's going to be shaped. So right here, right away, if I look at my A value, I know it's going to open up. So you might want to put your labels kind of on the outside there and keep in mind where it's going to go. Okay, so pause the video, attempt it on your own, and a solution will pop up in a second. Alright, and here in a guided practice 8, what if the maximum height of the football, what is the maximum height of the football if the football's path is modeled by this equation instead? So yet again, if I'm looking for a height, I'm looking for a y value. And the maximum, alright, the maximum, I'm looking for my vertex. So can you find your vertex? And with this model, it's actually going to be 15.625 yards. All right, if you approximate it as about like 15 or 16, multiply that by 3, you get somewhere between 45 and 48 feet. All right, so here in this method, you can actually change between forms. All right, it's important to know that I can convert forms. If you are uncomfortable with intercept form, you can put it back into standard form. All right, so what we're going to do is we're going to go through the foiling process. All right, so F stands for the first term, O stands for the outer term, I for inner, and then L for the last. All right, and then we want to combine our like terms. For typically speaking, it's going to be a nice trinomial with an x squared term. It better have an x squared term. An x term, and then a constant. So let's look at an example. Y equals -2 times the quantity x plus 5 times the quantity x minus 8 in standard form. So I'm going to make a recommendation to you, and that's just leave the -2 out in front and then distribute after the foiling process. Alright, so here we're going to do our first term. Alright, that's going to be x squared. Our outside term, that's negative, is going to be negative. Make sure it's negative 8 times a positive x, so negative 8x plus 5x, and then 5 times negative 8 is a negative 40. And then I want to combine my like terms, and that gives me x squared minus 3x minus 40, and lastly, I'm going to distribute that -2. And that is my final answer. Alright, so now it is in standard form. And here in example 6, I'm changing it from vertex form to standard form. So it's still even just a little bit different. So when I have a quantity written like this, what this means is I actually have x minus 1 twice. Alright, so this is called expanding. When I ask you to expand, that is what I'm asking you to do. Actually write out all of those quantities. So by expanding first, 4 times the quantity x minus 1 times x minus 1 plus 9, you can see that I'm going to go through the foiling process first. Alright, so let's see what they've got nicely written out here. Alright, we're rewriting it and expanding, and then we go through the foiling process. First, outside, inside, last. And then I want to combine my like terms. Then I'm going to distribute, and then I'm going to combine my like terms again because you can see 2 constants. And that is my final equation. Alright, so here in the guided practice, go ahead and go through the foiling process, save that A value for last. Okay, those were all taking examples from intercept form to standard form. Now we're going to have a couple of guided practice taking it from vertex form, so make sure to expand. Alright, and I hope you all do well, and if you guys have any questions, let me know.